Hi guys and welcome back. During the past two lessons, we've been discussing the Pythagorean theorem. Now we're going to move away from geometry and move on to rates, ratios, and percentages. Today we have three different real-life application problems to work on. Now for probably all of them, you're going to classify them and say, oh, this one's a rate problem, and oh, this one's a ratio problem. But truthfully, one can argue for both sides, because as long as a problem is related to rates, it can easily be transformed into one relating to ratios, and vice versa. This is of course also why I'm putting these all in the same lesson. Now, when we're dealing with these types of problems, there's really no formula needed to be memorized. All you need are logical thinking skills, as well as a basic understanding on how to solve one variable equations. Let's get started. Our first problem is the easiest one, and it says, there are a total of 63 people, and the ratio of girls to boys is 4 to 5. It asks us how many more girls are needed in order to make this ratio 9 to 7. So essentially, this problem is implying that we can add girls, but the number of boys cannot change. To begin, we know that the total number of people are 63, and the current ratio between girls and boys, we know that too. I like to think about a problem like this as if there are 4 groups of girls and 5 groups of boys. These groups are of the same size and they add up to 63 people. In other words, 63 people are split between 4 plus 5, so 9 equal groups. 63 divided by 9 is 7, so there would be 7 people per group. There are 4 groups of girls, so 4 times 7 is 28 girls. The rest are boys. 63 minus 28 is 35 boys. Now let's use an equation. What do we know about ratios? They can be written as fractions. The problem asks for the ratio of girls to boys to be 9 to 7, so 9 over 7 in fraction form. As we've stated above, the number of boys is constant, so the denominator of the fraction is just a simple number of 35. The numerator, however, is a variable. It starts off as a total of 28 girls, but we have to add a certain number of girls. So let's set that as x. So x is the number of additional girls needed to make the ratio 9 to 7. We can set up an equation of x plus 28 over 35 is equal to 9 over 7. Looking at this equation, my first thought is to multiply both sides by 7, so that at least one side of the equation, in this case the right side, can turn into a whole number. But when we actually think about it, if we do that, the left side is going to turn into x plus 28 multiplied by 7 divided by 35. And 28 times 7 won't be easy to do mentally for many. Sadly, if you're in a test, there's a high chance you'll be without your calculator. So you'd be happy to know, though, that there are better ways to do this. Let's look at the denominator of both fractions. The left is 35 and the right is 7. We know that 35 is a multiple of 7, and more precisely, 35 is 5 times 7. Try multiplying both the numerating and the denominator for the fraction on the right by 5. The value of the fraction won't change if you do this properly. We know that for all fractions. Well, we just said 7 times 5 is 35, so the denominator is now 35, and the numerator is 9 times 5, which is 45. You should notice that the two fractions now have the same denominator. Apart from that, you also know that this is an equation, so the denominator is equal, and the fraction as a whole are equal too. So therefore, for this statement to stand correct, the numerators have to be equal as well. X plus 25 is 45, therefore x is 17. To conclude, 17 more girls are needed. Next problem. Now this is one I personally experienced at a supermarket. It would seem easy for many, but many people get tricked with this type of stuff on a test, just as we do at a supermarket. So the problem reads, a customer must spend at least $100 to get a $50 coupon, which they can use on their next purchase, but the purchase has to be no less than $50. Overall, for this whole process, what is the maximum percentage of profit they can get from this deal? Well, the general principle for max profit is always spend less, get more. You can't change the amount of money that the coupon covers, but you can change the size of your purchases. So you'd want those to be as low as possible, and the lowest you can get in this case is $100 on the initial purchase. Many people might say, Derek, why are you calling this a challenging problem? It's easy peasy. And then they'll just jump to the conclusion that it's a 50% discount because a $50 discount buying a $100 product means you got something worth $100 spending only half of that. However, though convincing, that logic is flawed. Think about it. In order to use that $50 coupon, you must buy another product that's worth at least $50. Thus, in aggregate, after using your coupon, you've bought products worth a total of $150 at minimum. 50 is a third of 150, so the real answer to this problem would be a 33.333, you can go on and on with that, percent discount. So it's a 33.333% off. That would be the answer. Now, final problem. It says the juice company decides to mix leftover juice drinks to make a new drink. They have 450 liters of pineapple juice, which is 42% juice. They mix it with 630 liters of orange juice. The new drink is 35% juice. What percentage of the orange drink was juice? With virtually any problem, you always have to look at what the question is asking for and then work backwards to determine what should be your first step in solving the problem. For me, I would just start by calculating how many liters of juice are in the 450-liter pineapple drink. 42% of 450 is 189. On the screen here, you can see how I worked that out mentally without a calculator. Okay, there are 189 liters of juice in the pineapple drink. Next line of instructions, they mix it with 630 liters of orange juice. Well, that isn't much help without knowing any percentages. Moving on. The new drink is 35% juice. Here's something. What is the new drink composed of? It's composed of the 450 liters of pineapple drink and 630 liters of orange drink, which adds up to an aggregate of 1,080 liters of drink. Now we know that the new drink is 35% juice. 35% of 1,080 is 378 liters of juice in the new drink. It asks us what percentage of the orange drink was juice. We currently know the quantity of juice in the new drink as well as the quantity of juice in the pineapple drink. New juice minus pineapple juice should equal quantity of orange juice. So that would be 378 minus 189 is 189 liters of orange juice. So that's how many liters of orange juice you have within the orange drink. Well, the percentage of that inside the orange drink would be, let's see, 189 out of 630 is 0.3. So using the decimal to percentage conversion, we get 30%. That is the answer to the problem. Whew! There we go. We are done. Hopefully you've learned something or reinforced your understanding of percentages, ratios, and rates with these 3 real-life problems. Next lesson, we will be going into indices laws and scientific notation. Hope you've enjoyed this video. Please like and subscribe, and see you next time.